Hi there. This is a video for Intermediate Algebra. This is Unit 3, Section 1, Guided Notes. And what we're going to be talking about today are functions and relations. Okay, so the first thing I want to do is talk about what is a function, what's the definition of it. And, if you look this up online, they've got some weird, definitions for this. But my definition is for each x value, there is exactly one y value. Okay? And what I want you to think about is the concept of a computer. Okay? And so, computers are built off of the concept of a function. So a lot of times what you'll have is this thing called an input and then your output, okay? And so your input, which I like to call the button pressed, then you have the result on the screen, okay? And, when you press a button, only one thing happens. And so that's kind of the idea here, is that when you press the button, only one thing happens on the screen. All right. So like if I think of like a Word document or something like that, where it's like, you've got the Word document open, you press the K button, a K pops up. All right. It doesn't do other multiple things when it does that. Okay. So, what I want to think of, let's look at some vocabulary here. All right, so some vocab for this. So I used this concept earlier just now about an input-output relationship. Well, your input is the same thing as your x value, okay? And that correlates to then your y value. The other word that we have is we have domain. That means all these things mean the same thing, and then your range. The other vocab word, the other one that we have is what we call the independent, dependent, and then dependent. Okay. So these are all, vocab words that model this. For each x value, there's exactly one y value. For each input, there's exactly one output. For each element of the domain, there's one element of the range. For each independent variable, there's one independent or one dependent variable. So all these things mean the same thing, okay? So that's the idea, all right? So that's what I want you to take a look at for that, all right? So let's take a look at this. All right, and this example says, what are the domain and range of the function? Well, remember up here how, if we talk about domain and range, well, domain, those are x values. Range, those are y values. So if I wanted to list out my domain, I would simply do this. I'd write a D, and then I would write the little fun, cool squiggly line, and I would just list out my x values. And I would do 1, 2, 3, 4, and 5. All right, that's the group of numbers that represent my x values in this situation. And then your range would be the numbers 11, 12, and then 13. Now, the thing of it is that what we want to figure out is this a function? All right, that's the question that we ask ourselves. And so the thing that you have to understand is that does each x value correspond to exactly one y value? And so in this case, yes. And the reason is because the x values don't repeat. All right. The y values can repeat. All right. So what we can say is that the y values can repeat. And what I want you to think about when I talk about this is this idea where you have, think of like your phone and think of like the camera on your phone. How many different ways can you access the camera, right? Like you can access it from your home screen, You can access it from, your widget pull down thing on the top right. If you pull that down, and you can just access it from the app. So you have different ways of accessing it. That's why, like if you think of like, okay, how many different buttons can I press to get the same result here? All right. So X values don't repeat, but Y values can repeat. And that's what it means when you have a function. All right. All right, let's take a look at this one. This says a function can model each of these situations. What is a reasonable domain and range of each function? So what you have is you have a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So what we're trying to figure out is, what does our domain represent? All right, and what does our range represent? Okay. So remember that domain means that that's your X value. And what I want you to figure out is what does your X value represent? What does your range represent? And your range is your Y value. So in this scenario, what I want you to think about is that you're filling a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So the thing is that what depends on what, okay? So domain, your X value would be minutes, time. So it'd be time in minutes. And then your range would be gallons. However long you are filling up that, however long you're filling up that swimming pool will depend on how many gallons are in it. Now, one of the things that we have to understand is that, your domain, your X value, you can't have negative time. So your X value would be greater than or equal to 0, okay? Now your Y value, your range, remember, you can either have 0 gallons, okay, or the max is 10,000 gallons. So what you would do for this is you would say 0 is less than or equal to Y is less than or equal to 10,000. All right, and that's what I'm trying to figure out from this problem is, given this scenario, what's my X value, what's my Y value, and then what kind of numbers would I be dealing with here, okay? My X value, you can't have negative time, so your X value would have to be greater than 0, and your Y values would be between 0 and 10,000. Okay, so let's look at part B here. Part B says a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So let's take a look at our domain, which is our X value, and then the range, which is our Y value. Okay, so first thing I want to figure out is, what is our domain? Okay. And what depends on what, all right? So, here's the situation, and this is kind of a weird example, but it says a restaurant needs to order chairs for its tables. Well, one table can accommodate 4 chairs. Well, the question is how many tables do you have, all right? So, what we would say here is that X is the number of tables. And then Y would be the number of chairs. The number of chairs that you're going to order depends on how many tables you have. Now, here's the thing, is that, your domain, your X value still would be greater than or equal to 0, okay? Because you would need, if you have 0 tables, you're not going to order any chairs, all right? But let's think about what we would need here for the Y value. The range would be Y is greater than or equal to 4. Okay, well, let's go to 0. Y is greater than or equal to 0 because, well, if you order 0 tables, you're going to order 0 chairs. If you order 1 table, you're going to order 4 chairs. 2 tables, you're going to order 8 chairs. And so that's the idea, all right, between those. All right, so on this last one, or on this last page, the example asks, is the relation a function? If so, is it 1-to-1 or not 1-to-1? So let's talk about what it means to be 1 to 1. And what that means is that each y value corresponds to exactly one x value. So remember how I was talking about how how for, the definition of a function, you can have a function and the y values can't repeat, right, in the page before. But in order for the function to be 1 to 1, all right, what we want to think about is that the y values don't repeat, okay? And that's the idea. So here's the first thing. So if I look at this, if I want to list out, okay, what's my domain? Well, my domain is 1, 5, 7, and 8. And remember, I'm just listing off my x values when I'm looking at that. If I look at my range is 2, 6, -1, and 0. And I don't have to order these in any specific order, but here's the thing, is that, 1 corresponds to 2, 5 corresponds to 6, 7 corresponds to -1, 8 corresponds to 0. So first things first is that, yes, it is a function, all right, but it is 1 to 1, okay? Yes, it is a function, and yes, it is 1 to 1. And the reason why is because the y values don't repeat, okay? First of all, the x values don't repeat. That's why it's a function. And then we can say that it's 1 to 1 because the y values don't repeat. Now, over here, okay, this is called a mapping, okay, down here for part B. And these are your x values, and these are your y values, okay? So what we see is that each x value, 1, 2, 3, 4, 5, corresponds to just y values, right? But this is a function, so yes, it is a function, but no, it's not 1 to 1, okay? So it's not 1 to 1, and the reason is that the y values repeat. And one of the things that I'm looking for here, if I wanted to put these into ordered pairs, I have the point 1, 17. I have the point 2, 17. I have the point 3, 11. I have the point 4, 10. And I have the point 5, 10. So my x values don't repeat, okay? That's why it is a function. But then the y values do repeat, and that's why we would say, no, it's not 1 to 1, okay? So that's how we look at those. All right, let's take a look at this next one here. It says, in this example, the diagram shows shipping charges of a function as a function of the weight of several online orders. Based on the situation, what constraints, if any, are on the domain of the function? So here's the thing. This is x and this is y, okay? And what we, what we want to talk about here is that the shipping charge, the amount that you're charged in shipping depends on how heavy the box is that you're shipping, okay? So this is weight in pounds, and then this is how much you get charged, right? So what I want to look at, based on the situation, what constraints? Meaning, what kind of numbers are we going to have in our domain for this function? So what I want to do first is I want to take a look at this and say, okay, my domain represents the weight, all right? So the weight of our order. And the weight of our order, what I would say here is that our order has to be greater than or equal to 0. Meaning that, I can't have a negative number here. Sure, I can have 0. If my weight is 0, I'm not going to pay anything in I'm not going to pay anything in shipping. So, but the constraints that I'm going to have is that the weight of the x values have to be positive is the idea. And when the x values are positive, then we will have a shipping charge, okay? But we're not going to be dealing with negative numbers here, all right? All right, let's take a look at this last example here. It says, Margaret has a monthly clothes budget of $50. She maps the amount of money she spends each month to the number of items of clothing she buys. What constraints are on the domain? So let's think about this, all right? We have our domain, and we have our range, all right? And what I want to figure out is what depends on what. And when I look at this, this problem is weird, and how you read this sort of depends on how this works. But how I read this, it says she maps the amount of money she spends each month to the number of items of clothing she buys. So the domain is actually kind of the opposite. It's the amount of money she spends. Amount of money spent. And then range would be the items of clothing. So when we figure that out, all right, it's the amount of money that is spent, we want to know, okay, well, what are the constraints on the domain? And what we know is that Margaret has a budget of $50. So what we can say is that our domain has to be between $0 and $50. And how we would write that is as an inequality. We would say that x has to be greater than or equal to 0, but at the same time less than or equal to 50. All right, and that's the idea. Friends, this stuff is tricky, all right? We're not really doing any math. We're merely just thinking about, okay, what are our variables and what kinds of numbers are those variables? What kind of numbers could be those variables? So, all right, we will talk more about this. Let me know if you have any questions. Thanks a lot. Bye.